All right, so we've got a bunch of questions about trig identities. I did one of those, but we're going to look at another one here. And again, some of these are easy, some of these are way harder. So I'm going to try to show a couple more examples here of how you can do some trig identities. So let's look at, for example, tan A plus B. And this one's going to be a little different than the other video where I'm not going to show what answer I'm trying to get to. I'm just going to try to express this answer in terms of tan A and tan B. And the reason I'm going to do that is because I have formulas for sine and cosine where we have the addition of two angles, like sine of A plus B is equal to cosine A, cosine B, plus sine A, sine B. And so that's useful because that means I can figure out what the sum of two angles, what its sine is, based on the two original angles. And same idea with cosine. Cosine of A plus B is equal to, oh, I'm sorry. I wrote the sine one wrong. Please look it up. I keep making these videos without looking it up, and then I screw it up. Sine A cosine B plus sine, plus cosine A sine B. Basically with sine, it's flip-flopped. You've got the sine of one angle times the cosine of the other, cosine of the first angle times the sine of the other. Cosine is cosine A cosine B minus sine A sine B. I think I've made 3 of these trig videos, and every time I've screwed up at least once on writing down what those are. But they're correct now. So what I'm going to try to do is derive a formula for tangent in terms, tangent of A plus B in terms of tan A and tan B. So first, I think we would agree that because tangent is sine over cosine, tan A plus B is sine A plus B over cosine of A plus B. And then we can use those formulas that I wrote down correctly. Sine A cos B plus cosine A sine B. That's just the numerator. All over cosine A cosine B minus sine A sine B. And at this point, you might be totally stuck because there's no obvious way to proceed here. There's no like sine squared plus cosine squared. There's no common factors. One time when I was trying to do this, I multiplied by the conjugate of the denominator, but that just makes things worse, not better. But I want to remind you of what the goal is. The goal is to get an answer involving tan A and tan B. And the way you get tangent is you have sine divided by cosine. So let's look at our equation here. Wouldn't it be nice if I divided this piece by sine A, or by cosine A, because then I would have tangent. Like sine A over cosine A is tangent of A. Wouldn't it be nice if I divided this piece by cosine B? Because then I'd have tangent of B, because sine over cosine. Well, I can't just pick and choose what I divide by. So I'm going to divide by cosine A and divide by cosine B. Now at least I'm keeping it even. I'm dividing both of the terms on the top by cosine A and dividing them by cosine B. But that makes the fraction out of balance. If I do something to the top, I've got to do it to the bottom. So I'm also going to divide this term and this term by cosine A and by cosine B. I'm going to write everything out. It's going to look disgusting, but then you're going to see how this gets a lot better. So the top left corner becomes sine A cosine B over cosine A cosine B. The top right corner, cosine A sine B over cosine A cosine B. Same thing on the bottom left corner, cosine A cosine B divided cosine A cosine B. In the bottom right corner, sine A sine B over cosine A cosine B. Looks a lot worse. But remember, the inspiration was to force it to have tangent. And so I needed to divide by cosine to make there be a tangent in there. Then if we look at what cancels, cosine B over cosine B is 1, so it cancels. Cosine A over cosine A is 1. Here's another cosine A over cosine A. Here's another cosine B over cosine B. And let's look what's left over. Sine over cosine is tangent. 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 So after all of those divisions, we get tan A plus tan B over, both canceled, so I have 1 minus tan A multiplied by tan B. And there you go. That's the angle addition formula for tangent. So that was a little different because on some of the other trig identity problems, I tell you what your goal is. But on this one, we just set out with a goal that was vaguely defined. Change tan of A plus B into something involving tan A and tan B. So, thanks for watching. Let me know if you have any questions.